Everything that we want to build has to be explicitly defined. And if we don't define something, it's just not going to exist in our system. Whatever is not explicitly forbidden is allowed. We call this the feature constraint method.
And I think with this approach, like defining broad domains, that tearing down this wall between the builder and the user, I mean, this is the direction we can go. We should amplify the user agency this way.
Okay, so now this is us. We're Mateusz and Gosia. We're also the co-founders at Intentee, and in this presentation, we're going to talk about how we can build entirely new class of solutions with AI. Specifically, we'll talk about the tool we're building that will offer, hopefully, a completely new way of representing systems and applications, a new way of using them, and also a new way of building them. So I'd like you to think about how software is created right now. Everything that we want to build has to be explicitly defined. And if we don't define something, it's just not going to exist in our system. There is no flexibility. If something we want to have in the system is not defined, if it's not anticipated, it's just not going to exist. And this is this process of software creation that we've been trying to optimize for years, fix it even, I would say. And we have various techniques and even whole methodologies of work. We have business analysis to document and collect requirements, domain-driven design, more on the engineering side, user journey mappings, more on the design side, whole methodologies of work, like agile, more on the process side. The point is that we've been trying to focus on optimizing this process of the definition, of how to improve the definition. And we haven't really thought about, can we, instead of defining every little aspect of our application, can we just skip this definition and build systems in a new way? We now also have one of the most powerful tools we can imagine, language models, and more broadly speaking, this huge adoption of AI. And what we see, what seems to be, is that there are two paths for the AI. One is to accelerate, optimize, automate this current process of software creation. We can we can use natural language to generate designs, and then we can use convert those designs to code automatically. We can put co-pilots in our applications, generate copy, and so on. So we can make this process of defining, putting the definition much, much faster. But there is another path that we can take. We can literally flip upside down how software is being created. And this is the second path that we would like to explore, and this is the second path that we would like to make possible. So what does it mean to flip upside down the process of creating applications? What is the opposite of having to define every database schema, every relation, every piece of the user interface, every piece of the business logic? What is the reverse of that? What if I could, instead of defining everything up front, just say that this is my business domain and I want the system to act upon it? What if I can say that I have a bookstore and I need to run it, and the system can figure out the rest? Not by generating code, but by understanding what the concept of a bookstore means and being able to act on it and accommodate what has to be, what has to live inside this domain. And this not only changes the process of creating systems, but this also changes the process of using them, because we now can use natural language to interact with applications and systems. And I don't mean putting a co-pilot in a product. I mean that the intent recognition actually becomes the primary user interface. I mean that users can express what they need to do, and the system can act on it, can interpret this. But this also means that there is this wall that we have so far between using software and building software. This wall starts to disappear, because if systems are defined only by some general business domains, This means that there is no fixed schema that those systems enforce. So this means that builders define the general business domain, the boundaries of this business domain, and the users who use those systems can freely fill in those boundaries. They can freely add new facts into the systems. And this means that this line between building and using software disappears. And why is this important? Because this actually empowers users, especially non-technical business experts, to build the tooling they need independently. So right now, it's not even the fact that they don't have to understand how to generate, how to do code, how to do designs, but they also do not need to be able to come up with this idea of being able to define every little aspect of the application. They don't need to define every database schema, relation, workflow, piece of the user interface. They can simply operate by the terms that they understand well. This is my business domain. These are the goals I need to meet, and this is enough to build systems. So how can we achieve this specifically? How can I build systems by saying, this is my company, I need to track my suppliers. How can this be so that I can just describe this domain? Is it that risky? And this is where constraints come in. So in the systems, in this approach that we are proposing, the builders can define what is not allowed. They can say the book in the system has to have a price, or an order cannot be placed without a customer. So instead of what is traditionally being done right now in traditional software, instead of having to define what is possible, the builders only define what is forbidden, and whatever is not explicitly forbidden is allowed. And we call this the feature constraint method. So this is how to think about this. If you look at this circle, this is the business domain, this is the feature. And everything is open, everything is possible by default. And if you want to add a constraint, you carve out a piece of that domain. You make this specific part not allowed. And this is the opposite. This is this inversion of how we traditionally build software, because so far we start with nothing and we have to keep adding things that are possible. In this approach, we start with everything and we just take away things that should not be allowed, should not belong to the system. So the constraints kind of carve out the domain and make the shape out of the domain.
So I will try to talk about how to achieve this in practice and maybe give you some specific examples. So this is something we are currently building, and as you can see, you have this huge grid which represents a mind map of some system or application. And I mean, the interesting thing is when users will come to you, they will not think about domains, databases, all that. They will come with some specific issues to solve or with some complaints. So in this case, user is creating this mind map, right? So they drop like a feature gem that represents a domain, like loose domain, and they try to establish with the system, solve the issues with the system. So they say that they have issues with sorting out the vendors, the suppliers, because they can't make sense of this so-called tribal knowledge where people drop messages in some random places in the company and so on. So after they do that, they figure out that the domain knowledge is supplier coordination, which represents like this entire circle. They establish that they will need some agents in the wild to fetch data from external sources. So, and now somebody is using the application, right? So we have someone saying to the system that a new shipment has arrived. For example, 5,000 boxes with magnetic leads came to the company, right? And someone needs to service them. And how can we make sense of it? So what is interesting? We were looking for ways to represent such systems. And usually if you start I mean, working on some piece of software, you start with some relational database or some document-oriented database or maybe graph database. And we were looking for some database that would be able to represent this loosely related data. And we really weren't able to find anything that would like match this system exactly. At one point, we took some opposite approach. So we sat down with a piece of paper and started to design like this imaginary perfect database, this data storage that we could use. And we came up with a simple table that represented a list of entities and some tags that represented properties. So it was something between graph database and document-oriented database. And at that point, we figured out that we are just reinventing RDF, which is like resource description framework. So resource description framework in its roots dates back to the 90s. Originally, this technology or specification was invented for web crawlers in the early days of the internet to index whatever was possible to index from websites, from this loosely related random data. And this kind of surprising something is how can we do this kind of archaeology to dig out some old technologies that have new applications in this new world. So what you can see here is a set of RDF triplets, I mean simple subject, predicate, object. And this was generated by AI, of course, from this single sentence. So you can see that we have a lot of data, a lot of information that is related to the general domain that user defined. It even has some assumptions, that fulfillment benefits organizations and such, so it even might be used for guardrails and with the AI, right? So we extracted all this information, and it is enough to operate in a certain domain. So let's say that user continues to use the system. So we have a situation where, for example, one supplier was responding, the other wasn't. And user just commented that, okay, just do not use the suppliers that are unreliable. So we created a constraint. So we cut off some part of the functionalities from the system. And I think this is where the line between like builder and the user should blur. And this entire situation kind of brings to mind the story by Isaac Asimov, The Last Question. And in that story, the humanity had access to AI so powerful that it became invisible to us. So people were talking to the void, and the void answered back. And I think this is where we should go with it. But at the same time, in the story, the humanity kept the agency and kept control over our fate. And I think with this approach, like defining broad domains, that tearing down this wall between the builder and the user, I mean, this is the direction we can go. And we should amplify the user agency this way.
So to sum up, the traditional way of doing software is heavily based on the definition. We have to define every database schema, relation, workflow, piece of the business logic, every piece of the UI. What we propose is that users can only define the broad domain, the business domain within the domain that they operate in, and this is enough to build software. And this software is built on this semantic foundation. And we would love to work with researchers who would love to also look into how we can use the semantic foundation, the triplets, and how we can build systems upon them. We would also like to start working with the builders who are interested in building in this new approach. So please feel free to reach out to us. And thank you. And of course, if you have any questions, we'd love to answer them. And oh, I was always the one with the mic. It's okay. Yes, thank you.
Who was it?
Hey, so I think I understood most of it, and I agree whatever with the rules, but I didn't understand this transitions that you mentioned, that the most important part for the user to define what's not allowed. So you were talking about like general rules, like what's allowed, what's not allowed, and how it's mapped to like RDF, and then you said like the most important is like what's not allowed, like, and I think I'm confused there, and like maybe you have more details. And then the second part is I assume that in your model, whatever, like in RDF model, rules also can be like whatever, like timestamp, right? Because those things also change with time. Like I don't know, like maybe like even like with books, you think you know the rule that you like every book should have a price, but then suddenly you realize that you also want to donate books, and now the book has price 0. So like, is that also like in your model, like this the timing of the rule? So it's two parts.
So instead of like defining everything up front, if you say that you want to manage a bookstore, we can implicitly assume that your system will need all the functionalities that the typical system needs. So if you're building a bookstore, you will most likely soon need like to set notifications to users, send emails, manage like returns, be able to do this and that. And I think in a perfect world, we can assume that every functionality could be enabled by default. So the default state, if you define a domain like that, you can do everything with it. You can order new books, you can catalog them, and so on, so on, so on. And this type of information is really loose. So you can use some format like RDF to store them. So this is where this comes in. And if you need to introduce some limitations to it, or you need to introduce some like specific constraints, I mean, this is also important. So we try to represent that by the circle. So you can define the application like that, but just by describing the domain, implicitly you have all the like features, functionalities enabled, everything that you can imagine, everything that eventually happens to be a part of a typical application. And then you can just cut off the corners. You usually can say, okay, but you shouldn't be able to do that, or maybe you should do specific things in certain way, and so on. So that's the idea.
Okay.
Thank you. First of all, thank you for your presentation. Very interesting approach presented. My question also comes from confusion. As a product builder, I think it's much easier to define what's the application and what's the use case that the application must solve and what are the jobs to be done as well, than defining the unknown, which is all the edge cases of what shouldn't be possible as well. So I was confused by that, and my question is, what's the advantage of this approach versus greatly built, opinionated product for, let's say, specific niche of bookstores, where user can just log in and have all the features needed to run that bookstore, right?
So there is this assumption that if you start working on some application, right, you will eventually need to be able to like add more and more features. You will end up with system that I mean, let's be honest, most of the systems have similar set of features. You can really boil it down to some set of like you have a few entities defined, relations between them, you have some messaging, this and that. And why not I mean, so the general idea is to assume that this is the default state, that you can do everything imaginable with the data. You can process it, the connections in any way that that is imaginable. So you don't have to spend time on defining those requirements, and then you can let go. So the biggest advantage is to let go of control of the application and blur this line between like builder and user. So instead of builder defining everything, instead of builder introducing the constraints, we kind of imagine this perfect world where you have an organization with like, I don't know, maybe 1,000, 10,000 people. And you do not have this division like builder and user. You have something more along the lines of like a leader who just, or a person who creates this kind of constitution for the application, right? A few basic laws. For example, we are doing bookstores, or we are doing packaging, or we are doing something. And then you don't have this like a central entity, like a product team or AT, who interprets all the requests. Instead, you can just let go of the control and allow users to expand domain, introduce constraints. So I think the biggest value would be in like empowering everyone else besides IT. So this is the general idea.
Okay, I would like to ask my question before.
And you
if I
have the
can.
mic. Okay.
I have the mic. This is a very, very interesting approach and something completely different than we are used to. It does remind a little bit what happens now with OpenClaw. I don't know if you are following what's going on there. It's like you can do everything. You can connect any agents and whatever. You can like you start from this from this state. Have you thought about the security of those systems? Because like the assumption that we have only builders and users is very limited. You have also adversaries. You have people who want to do harm. So like, what's your thoughts about that? Because for me, this kind of removing constraints is really never perfect. You can always find ways around, much better, much more than if you just add things from zero, because you can only do this and that. So what's your thinking there? Like what should be the guardrails that? And also second question, like how does it relate to Prolog? Because like these rules and everything, I don't know if you know Prolog, the language from 60s, I think, about like when AI started. So Prolog was really these kind of things, like you find some rules. Like now those rules are generated with AI, which is cool, but then the Prolog was like logic language that was actually implementing the rules. That was, so two questions, sorry.
So like the comparison to Prolog is interesting. I haven't coded anything in it, but that kind of gives me an idea what you might be talking about. So the security model is everything is, so you need to explicitly define permissions. You need to explicitly allow someone to do something. So on one hand, you have this open model where all the product functionalities are enabled. Everything is accessible to everyone, and you just cut away pieces of it. But the permissions should be the opposite, I think. Everything you need to be able to allow specific people to specific things. And I think most of the security issues that come from like open cloudbot or I don't, they change name every week, but whatever comes out of that is because you have leaking like API keys, using software that isn't parsed, this and that. So you have this like open world assumption. You can pick whatever is there, whatever software exists. But with this approach, you do not use code, right? Your application is purely data, purely relations is in this data set. So you do not introduce software, you do not introduce security risks like that in this sense. I mean, the worst that can happen is not that, you will introduce some unparsed piece of software or expose your API keys. The worst that can happen as an author of the application, maybe you will allow someone to do more than they should or something like that. But it will not be even close, I think, to what happens with like this random unrestricted generated code. And you can even have new class of guardrails. So not just software security itself, but AI can reason in ways that the author of the application does not always need to think about, or sometimes they will never think about. So you have this simple statement here about some boxes coming to the company. So I can reason, for example, that it benefits the organization, right? So you can introduce new security guardrails that are not just based on software patches, but are based on some semantic context even. So in a sense, it has a chance to be even like better than we had, really.
Okay, thank you. First there. They were first.
Thank you for this inspiring talks. I'm teaching interaction design, and this is something really like this opened my mind. And I have a question, like, kind of like from a science fiction maybe area. But if I understand it right, you define the user as the administrator of the system. So in the book store case, it's the owner of the store, for instance. But do you think that in the future it might be also the client? I mean, the person that is coming to the store, and for instance, see that, well, I would want to filter your books by a specific filter. Can you do that for me, just for me, right? This feature.
So I think that when Tim Berners-Lee created World Wide Web, he wanted every page to be open and editable, which was a good idea to have. Initially, we thought about, so it starts to be about trust circles, right? So initially, we thought about having people in the same internal teams in companies. I would love to see the world where customers and the users of the application can contribute to it, like in meaningful way. So yeah.
Sorry, maybe just a quick. I wanted to add one thing, that because there are ways to create things that just on your computer, like in your cookies or in JavaScript, right? It's not for everyone, but just for me for that moment. Right?
Yes, so that's one of the approaches, but something that I would like to kind of like touch upon what you said a moment earlier is, so in this world, absolutely users can extend the systems that they are using. So this is coming from the fact that if we have systems defined as business domains, they don't have that fixed schema they need to like put on the data that is supposed to be inside the system. And thanks to the triplets, representing data of the application as triplets, users can very freely add new facts, new relations, and this way extend the system.
Thank you.
Thank you very much for presentation. If I understood the concept right, so any system, any existing system that we are used to build is actually a derivative of some human intent, right? But but as we have all our boundaries and all our limitations of existing infrastructure and industry standards, how we are building the system, right? You are actually trying to kind of give the user a way to change the system behavior, right? Freely, right? Make every user the creator. So first, my question, like, have I understood the concept correct? And how to deal with the fundamental problem that usually user do not really understand what they need, and only after many iterations it becomes clear how problem has to be solved in more efficient way.
So you mean something like, sorry, the name took, I forgot the name, but who said that? Heisenberg maybe? Let someone correct me if I'm wrong, but there is this famous physician who said that we cannot achieve truth through linguistics because every expression, every word, every phrase we use is not 100% accurate. So therefore, by this logical reasoning, words, rhetorics, we cannot achieve the truth, right? So I think this is something similar to what you said, right? Because we rely on the ability of the user to accurately describe their problems. But I think that we have LLMs now, right? And we kind of rely on them to be this translation layer between user and the system. They can ask questions. We assume that users will not operate with solutions. They will come with problems, with complaints. They will start with something emotional, even, right? So we rely on LLMs, AI, to be able to interpret that, to define that more. So, we are standing on the shoulders of the giants, right? So this is one of the foundations we choose. We trust that it will kind of do this for us, that it will understand the user intention, translate it into something more structured.
Hi, Do you have any specific class of problems or category of software that will be built initially with this approach, where it fits more than yeah, where this open-ended approach may be undesired or harmful? What would be the simplest, next best step to make it an MVP or something that people can really touch and use?
So we have been thinking about this a lot. I will start and let Gosia also say something, but we were thinking, so obviously if something is really algorithmic, like you will not do like some microcontroller firmware for some specific hardware. There are limits to that. Where I think this will really shine is where you have a lot of collaboration, a lot of communication, a lot of tribal knowledge, a lot of places where people throw some random facts in random places, where people make important decisions on Slack, where they put documents on Google Drive, where they need to make sense of it, in situations like that. We were thinking that, for example, consulting companies may benefit a lot from this because they work with random requirements, maybe labs in financial companies. So we are thinking that those might be the places where this approach may shine.
I actually wanted to say the same thing because, yes, just to kind of like reiterate, one of the perfect like environments for this kind of applications is where the like communication is extremely important and where the knowledge is scattered across many data sources.
Yeah, and also it should help a lot where you work a lot with people with random requirements, where the requirements and the applications, the environment changes a lot. So I think the key is both communication, environment that rapidly changes, and a lot of unstructured communication, which, I mean, to be honest, is most of the companies in some sense, I think.
One last question.
Last one. Thanks for the presentation. Nice callback to PackHub, Gosia. So what you're proposing is a kind of a paradigm shift in thinking about creating software and products, basically. So you're proposing the client, the user, to be the creator of bespoke solution for them. So the idea here is, I'm running a bookstore, do everything for me. So is that the idea here?
Yeah, so the way we see this world is that the builders and users are extremely close to each other. And of course, we are also like, we do understand corporate constraints and environments. We do acknowledge that builders define the boundaries of the business domains. But the thing is that users should be able to very freely add new facts, new relations into those systems. And kind of like one of the biggest problems this solves is that normally when we build software, we have to anticipate everything up front. And I'm going to make a very simple example, but imagine you have a system to put some information about, let's say, packaging, and you have to define the form, and you have to define every field. If you don't anticipate something, it's just not going to be possible. Like, you have to make a feature request, and that's going to take time, and so on and so on. Like in this world, the user can add a new fact about the packaging, even if the builder did not anticipate this. Of course, if there are facts that should not happen, this is why we have constraints.
Okay, thank you.
Yes, I think.
Do we have time for one more or not? Because there is one more question.
But the last one.
The last one, thank you.
Okay, perfect. So my question is, just to clarify my understanding here, not only you propose a new paradigm here, right, a paradigm shift to how the software will be built, but also, yeah, perfect slide. I wanted to ask about this one. So you were saying that the constraint will be just that piece carved out from the circle, right? But the actual constraint would be that I'm running a bookstore, right? Because I'm not running a packaging company or whatever. So this would be already a constraint here, right? And as a like continuing that thought here, So do you think there will be some pre-made set of features, like for the prompt, let's say I'm running a bookstore, like I want to iterate later on that approach because my bookstore needs some like unique selling point, right? Like, or another key differentiator here. Sometimes, you know, like the UX or UI can be the unique selling point here. You're talking about more like from the backend perspective, I guess. I'm wondering like how it all connects to each other.
So I'm guessing you're asking about the UX of using systems built this way?
Yes, and then how adapting the software to individual business needs, right? Because I don't think you will assume that every bookstore now will look the same, will work the same way, right? And will target the same user groups.
Yes.
But we can assume so that all of the bookstores and all of the systems we build will have like, so again, this set of features, because if you develop the system long enough, you will end up with some standard set of features. You will need some database, you will need a set of relations, you will need some way to contact to your users. These features are repetitive. So why not like take all of them, make them a default part of, for example, this platform, and assume that every application that user creates, every system has them enabled by default. And only by users saying that this should be done in a really specific way, or we shouldn't do this, or by introducing those constraints. So this is what differentiates the systems. Because I think the problem with our industry is we are reinventing the wheel a lot. And as Jarek said, 90% of code we use is open source. So we are adding this thin layer on top of it, right? So we are in this tip of the iceberg. So why not just assume from the start, okay, every application created with this approach will be able to do everything we can imagine, like notifications, this, that, whatever. And the way to differentiate is once this tribal knowledge the company has, the people who work on it, your trust circle, and it's all in the business, right? So you have all the tools at your disposal.
Okay. Thank you very much. Thank you.
Thank you.